Hey there, welcome back to the stream. Today, I think we're going to be working on, well, I know we're going to be working on the YoshiStat. So today, we're going to be working on the YoshiStat, which we're just using the YoshiPi hardware here to create a smart thermostat. So basically, we're replacing this dumb thermostat that I've got installed upstairs. Now, I've done a bunch of code over the last, I don't know, I think 7 episodes, something like that. We've done code for quite a bit, and we're now to the point that I think we can start thinking about using this to actually drive the HVAC. So really what I need is I need to take this, and I need to get this mounted up on the wall in place of where one of these goes. Now these hook on with a back plane. And let me show you this on the bench. It might be a little easier to see. So this is the back plate that comes with it. And this hole distance here is a standardized hole distance. Now, sometimes they're mounted like this, and sometimes they're mounted vertically. I probably have half a dozen thermostats of different varieties here from jobs over the years. But what I need to do is I need to replace this with something that's going to hold this YoshiStat. Come on, focus. Hello. Come on, camera. There we go. So what I want to do today is I actually want to build a backplane that allows us to mount this. Now, a finished product, you've got, this nice enclosure with buttons and everything. This is not going to be the end product. What I'd really like to do is spin a board that holds all of this, so the display, the Pi Zero, and all of its associated stuff. So shrink it down, and the height, you can see the thickness there. It's about the same as a standard thermostat. It'd be nice to take this Pi Zero and maybe get it underneath. We've got some standoffs here, and in fact on the display, that make everything tall. So if we actually just went through holes to a board and soldered it down instead of having removable components, it would make the whole thing thinner. So we might be able to stack things up and get, instead of having to have the Pi and the display side by side, we could maybe stack them. Again, that's not overly relevant for today. The point being is we're going to make the finished product small, probably about the same size as this. In fact, that might be a goal size for a finished thing. But before I go through the effort of spinning a board and doing all of the stuff to put it into something like that, I want to take this prototype and make sure that it actually works. So I want to take just this as it is, and I'm going to mount it on the wall. One of the other things that I really want to have in the final is we've got thermostat wires that are coming in. So we've got 24 volt AC that's going to be coming from the wire from the wall, and I want to use that to power this. This obviously is not powered by 24 volt AC, so I think what we'll do for now is we'll just use USB and then run that down to a wall wart or something like that to power this in the first iteration. I can get it mounted, make sure everything works, and then I can develop some sort of a power transformer, power converter that I can just mount up here that will take that 24 volt AC and convert it to 5 volt DC and drive everything. So that might be one of the next videos we do, is figuring out power. But the point again here is I'm not going to worry about power right now. What we're going to do is we're just going to assume we're going to USB power. We're going to use these screw terminals. Now these screw terminals have to have wires that then go through basically a hole in the back. So there's a hole in the wall that this runs through. So typically you've got a couple of anchors, and then this just goes straight through the drywall. Usually it's just punched through with a drill or screwdriver or whatever. So we need something that we can hold this, that will mount to these, that has a hole in place that allows wires to come up and into here. So we've got a few different, requirements that we need to meet, but otherwise it's not a whole lot. Now, one thing to think about also is the way this one works is this gets mounted to the wall, and then you just take the thermostat and it snaps in. And it's got these pins that just bayonet into these connectors here. So you mount this, and then you can just walk up and slide this on. Obviously, I don't have that kind of connector here. So we have to have the wires, that'll loop up and hook into here. If I'm mounting something onto something like this, so I need to be able to put the screw holes in, obviously they're going to be behind this board, so that won't work. So I have to build something that I can mount to the wall, and then this will mount into it after the mount is on the wall. So that's a little bit of a challenge. I think I mentioned that since this is a prototype, we don't need to do a full enclosure and face. I'm not worried about that because there's no point in spinning all of that if we then turn around and make a smaller board. So really all I need is a backplate board that holds this. Yes, it'll be ugly and it'll just be hanging out there on the wall, but for a prototype, that is just fine. So today we're going to do the 3D design work in CAD for a backplate that meets all of those requirements. Let's enumerate them real quick. Just a backplate. It needs to have mounting holes at this standard configuration distance. I am going to go horizontal because I'm designing this thermostat horizontal. Though that would be interesting if you could make it so that it could go horizontal or vertical so that the user could, decide how they want to mount it and then use configuration to rotate. Constantly thinking new requirements for this. But for this one, holes for horizontal, a hole for the wires to come through, and some way for the backplate to mount to the wall, and then this to mount to the backplate. One other thing to consider is this is, it's just flat. Obviously, it's on standoffs right now, but if I took those standoffs, I can't just mount it right to the back plate because wires have to come up and around. So we need to have some space between this and the back plate, whether it's using these standoffs or something else that is to be determined. So let's open up Fusion 360, which is my choice of design software, not for any particular reason other than I know how to use it. So the first thing we need to do is we need to create what's called a sketch. And so I'm going to create this sketch. I can open up the right view here. So I'm going to create a new sketch. And in fact, it's already created this one called Untitled. You can't do much with it until we actually save it. So I'm going to call this YoshiPi, YoshiStat Proto Backplane. All right. And it's going to save it off, and I can shrink this, I think. There's got to be a way to do that so that we don't have to eat up a bunch of real estate with this. I know I can do it. I just don't remember how. There it is. Okay, perfect. Okay, so I know we need a rectangular base plate. So I'm just going to start designing. I'm going to put it here, and we've got a rectangular base. Really the only tool I'm going to use here is this. I'm going to use a caliper for basically all of the measurements that I run across, And I think that's really the only tool we're going to need today. So I know that it needs to be the size of this. So what I typically do is, now the temptation might be to just design the back plate here. My experience is that I usually like to at least model the thing that's going into the enclosure or backplate first, and then design the enclosure around it. I do have some 3D designs for this hardware already done, but I'm going to not use those. I'm going to just design them here so that you can kind of see that process. Now, there's a whole bunch going on here, you know, buttons and screw terminals and connectors. Those largely don't matter for what we're building, so I don't need to worry too much about it. I do have to come up onto these, so I might put these in, you know, the power and the relays and the digital outputs. Maybe, maybe not. The reality is, if we have a backplane that doesn't extend up past this, I won't need to worry about it, but we'll decide as we go. Point being here that I'm going to design at least a very rough sketch of this hardware first, and then we will design the backplane around it. So let's actually create another sketch. I'm going to finish this one, and I'm going to create another sketch, and we're going to call this the YoshiPi let's call it YoshiPi board, something like that. So let's create a sketch here, put a rectangle on, and so we know that it's a rectangle, and I've got some circles, and I suppose I should change back to here so you can see what I'm doing. So we've got some screw holes, right? And we actually have the Pi Zero, and we have the display, and we do have, oh, we can just put these in. Just broadly, we've got these connectors, right? So these are our shapes of what I think we care about for this. In fact, it's more than we care about. I'm not overly concerned about the display, but we can put it in. Now I'm going to start putting some constraints onto this drawing that will make it a lot more, you know, along the I'll start putting constraints on this to make it look more like reality. So this is where measuring will help. In fact, trying to decide if it's worthwhile to have the camera showing measurements too. Why not? So hold on 1 second while I add that in. All right. So what we're going to do is first, I'm going to deal with the dimensions of the board itself and then we will do the dimensions of the things on the board. Now I've got measurements. If I can go into Easy EDA, and it'll show me exactly what the measurements on this are, but I find it's just so much nicer to show people how you do this in a real world. If I were to get this in the mail and I didn't have access to it, or I just bought something like this. So I am at 91. That's a weird size. Too big for the caliper. Oh. All right, we'll have to do something like this. And then I'm going to center this on the origin. So the origin is here. And if I center it, it's going to basically constrain it, and the outline will turn black so that it is in a fixed location. The easiest way I find to do that is just say the dimension from one edge to the center is the overall length divided by 2. And again, edge to center is the overall length divided by 2. And then that centers us. Now the screw holes, that is a 4mm hole. So I can say that this is a 4mm hole, and I know that this one is the same as this one, same as this one, and same as this one. So all four the same size at 4mm, and then let's measure it to the edge. So that's 3 to the side of the hole, to the center of the hole, therefore it must be 5, right? So what I'm going to do is I'm going to put in another rectangle, but I'm just going to make it a construction line. Here. And now I can take these circles and put them right at those corners. There's a little bit of a zoom on what it is that we're looking at. Next, let's deal with, let's do the display. This display is 55. Yeah, we'll call it 90. Now, when we're laying out things like this, I've got multiple things that I need to lay out. Generally speaking, I like to lay them all out from the same edges. So I'll use one edge for X and one edge from Y. So basically, all my layout, I will come from here. So measure this direction to them and this direction. Because if I measure this direction sometimes and then measure this direction other times, what you'll end up with is if your initial measurements were off even by like a millimeter, you can end up with some weirdness in the middle when things get close to one another because you're measuring off of different edges. So if you always come off of the same edge, you're going to do a lot better. So let's see if I can, this is kind of hard here because it's up in the air. Put the Raspberry Pi in here. And already I've got a measurement that's incorrect. Let's try this one again. That's better. And again, you could always go look up the actual dimensions for things that are common, like this Raspberry Pi. I'm sure the dimensions on this are published. This rectangle here is the block of screw terminals. You can see we've got several of them here. I'm just going to do this as one big block. Because for what we're doing, it doesn't need to be really a refined model. All right, so I think that is all we actually need for doing this. So that's our sketch. Now, let's actually build the board. So the board itself has a thickness of 2 millimeters. And let's just put these on. And you'll see that these are not going to be refined at all. So that looks like that's, say, 9 millimeters. So what I'm going to do is say this. We're going to come up 9 millimeters. And that's it. That's all I'm going to do. Now, if you wanted to get somewhat fancy, you could do something like this. You know, we could take this and let's chamfer it. And I could do a 2-direction chamfer. And it comes in, I don't know, maybe like that, and maybe like that. And we could do the same thing over here. Nope, not rounded fillet, chamfer. I don't know, something like that. Again, that doesn't really matter. The angles there, that's more refinement than we actually need for our model here. Let's look at the display. The face of it is up 17. So I'm going to just come up 17. And the face of the Pi we'll call it 10, close enough. the measurements here don't need to be terribly accurate because, again, I'm not building any kind of an enclosure over the top of it. Really, the things that are important are things that we need for mounting. So the hole sizes, the distance between holes, the board size itself, the board thickness. Really, those are about all that we need to be terribly accurate on. So there's our board. I'll save that. Now I'm going to come back here, and this is our back plane. And what I'm going to do is come back over and show this, and I can take the board, and I'm going to drop it in. So now I have this board has been imported into this drawing, right? So now I can build my other stuff around it. So this is where our back plane is going to be. So now let's edit that sketch again. What we can do is we can project onto it and to do move some things around in the timeline. Let's go back and now edit the sketch. Okay, so what I want to do is I want to project onto this board. Really, that's all we care about, right? We can project that. Then if I hide the board, it projects. I mean, it's missing this edge and things like that, but really it's got the 4 edges that we care about and the holes. So I think that's going to be good enough. If we make that 5 millimeters, so it'll extend 5 millimeters out, that should work out just fine. Oh, looks like the dog wants to go out and go to the bathroom. So I will be right back. If you have any questions, go ahead and throw them up into the chat, and I'll answer them when I get right back. All right, and we're back. Okay. What were we doing now? We were doing this. Now I could make parameters for this whole thing so that I could adjust these, but this is so simple that if I need to change these, I can just change the actual dimension. What did I do? Okay, so our back plane is going to be basically a 5 millimeter margin all the way around, bigger than the YoshiPi itself. Now I kind of want to have some sort of a ridge because just a flat piece of plastic is pretty floppy. Let's do a couple of things. First, we want to put the mounting holes. So let's actually come back and measure this. So we know that these holes, let's go center to center. Looks like it's 82 millimeters. Now you can see that these are ovals. They're not just a round hole. And it allows you a little bit of wiggle room to straighten things out. And we're going to do the same thing. So I'm going to put these here, here, dimension. I guess we need to put a line in because it was center to center. And our dimension from this center line to this center line was 82 millimeters. And I'm going to center those. So from the origin to here will be that dimension divided by 2. So now we're centered across the middle. Just quick sanity check. If I did that and I put the hole right at the edge of this, it's in the display. So that seems reasonable. All right. Let's set the size of those holes. I think this is actually probably a square with half circles. I'll show you what I mean there. But they're 4 millimeters across. So if this is 4 and this is equal to that. And now let's do an arc. I guess we could do a center point arc. Nope. Needs to be a standard line. And I think the dimension from here to here is probably the same as this. Now we need to put these on the center line. I already screwed that up, didn't I? This one's horizontal and this one's vertical. So let's remove that one, and do them the other way. There we go. And we might as well make the hole for the wires here. You can see on this one, it's not centered. Actually, it's not centered either direction, but I don't think it makes a whole lot of difference. We could have this mount a little higher on the wall where the wires are lower, centered. Let's just center it. Why not? Similar size hole. What is that, about 15? Yeah. 15 by 35-ish. Let's call it 15. Hey, let's just make it 40. And we can even be a little bit fancy here. And we can fillet those, right? Nope, didn't want to do that. I want to continue working on the sketch. So from here to here. Let's just do a 3. Yeah, 3. Why is it allowing that? Ah, there we go. All right, so that gets us our hole for the wires, gets us our hole for our screws. Now we just have to figure out a way to mount our board to this. So what I was thinking is I almost want to have maybe some sort of slot that, let's say, the top fits into, and then we slide this down and it clips in. So we want some sort of a standoff to keep it up off the back, and that can be in all 4 corners, basically like these, but we'll just build that right into the enclosure. So I guess we could put these into the enclosure with screws. A lot of ways we could do that, but let's just do this. Let's say we want to I want to make a rectangle around the border to make it rigid. This will make a little bit more sense when I actually extrude it. Let's see. So from here to here, make that 3 millimeters. Why? Because of that one. All right. So let's go extrude this just as we have it so that you get a feel for kind of what we have. We can do this in stages. So let's say we want to extrude this and make it 3 millimeters thick. So we kind of have a plate that looks like that. Now these holes, they don't necessarily need to be there. We could fill those in, but we'll worry about that as we continue this. Then I want to take this one and I want to extrude it in the positive direction. Let's come up 2 millimeters just to start with. So you can see if I shut off that sketch, we have this ridge that runs all the way around now, right? And this will add some rigidity to the plate itself. Now, that is not enough. We know we have to have space, behind the board. And in fact, if we show the YoshiPi board sitting here, we know that we want it to be moved up, right? So in fact, let's move it to where we want it. Move the whole component. Come on now. Oh, interesting. So what it has done is it has merged our two bodies together, which I do not want. That's why I'm having trouble here. So if I come back to here, hide that. Mm. Somehow I grounded it. Now I'm trying to figure out how to undo that. There it is. Okay, now let's try this again. I want to move that. There we go. That's what we wanted. So now I can move this up and down, right? And really what I want to do is I want to move it, I think it's 0 is the faces of them combined. So up 2 will be sitting flat. And then we want to come up another 5. So that should leave us a 5 millimeter gap between the back of this board and the front of this, I think. Let's go take a look. We inspect from, say, this to this. It says, yep, it's a 5 millimeter difference between them. And 5 millimeters is plenty for those wires. All right. So this is kind of what we're building right now. Now we have to have a way to attach this board to the back plane. I'm thinking a reasonable way to do this is if I had a slot or some sort of way that this upper edge could slide in, and then some flexible tabs at the bottom that would hold it in place. So let me kind of show you what I'm thinking here. Create another sketch just for this mounting. And then let's project this back plate onto it. And I want to project these edges. I do that, and then I hide all of these. I do something like, let's just do this. All right. This might not be real obvious what I'm doing here yet, but hopefully it will be in a minute. All right. So what I want to do, let's worry about the top edge first here. So let's do that. So we're going to bring some posts up like that. And if we show this again, so let's create a sketch on this. And we'll project this edge onto it. And actually, let's project this on as well. Right, so we've got that. So what I can do, let's come down, say 0.25. Sure. Seems reasonable. So look at what we get when we do this. I'm going to show this body again. And I'm going to hide the YoshiPi. And then I'm going to take this and this and extrude those. I'm just going to drive it all the way through. So that cuts a notch like that, right? And the YoshiPi fits right in there. And we've got, if I zoom in, hide that sketch so it's a little clearer. You can see we've got this 1/4 millimeter gap. When we 3D print this, that's going to eat up that 1/4 mil, no problem. Gives us a little bit of flexibility to move around, right? So now we're mounting it, holding it here. And I'm going to do something similar on the bottom, but there I want a flexible tab. So kind of you slide it in up here. And then at the bottom, it'll have a tab that moves basically down that the board can snap into. So they're going to be thinner, right? We don't want it to be thick like this because this isn't going to flex. We want it to be thinner so that it can flex. There's the risk that because we're going to have to print it like this, it might delaminate due to that flex, but I'm going to print it and give it a try. So let's go back to the sketch. I can hide that again. Show this sketch. Now, these ones we want to project up. You can see already that these ones are thinner. And with a little bit of creative chamfering, we can make it work. So we're going to extrude these up. Let's show the YoshiPi again. And we want these to come up. Let's say 15. Ooh, not 10, 15, just 15. That's probably more than we want. Let's call it 13. Actually, let's go 15. I'll show you why. Once we thin this out, that's gonna, it looks thick, but it's not gonna be all that chunky. Let's hide this. In fact, let's go back and work on this sketch because we can, oh yeah, we can just blow that all the way through too. That works great. So I think it was this extrusion. Yes. Let's move it. And let's edit it. This single extrusion we will use to go through all of it. So now we have all of these. And this looks a little sus here, right? It's really chunky up on top. But what we'll do, there are a few different ways we could do this. We could use a chamfer and thin it out, or we could create a sketch and thin it out. Let's do a sketch. What the heck? The great thing about doing 3D modeling is you can be very creative and do whatever you want. So let's do a sketch on this. And let's do just some lines. We're going to come from, say, the middle here to even right here would be fine, right? Let's make that 1.5. And it might be as simple as that. Let's do an extrusion of that all the way through. So now we have this notch up here, and it comes down and it clips in. Now this notch is fairly deep, and I'm concerned that when you try to push the board in, you're not going to run into here. I want to give a little bit of space. So let's do a chamfer on this. And let's come up. Now let's come on now. It doesn't want to let me. Okay. So let's come in. 2. Let's try that. And I want to do the same thing on this one. Where'd it go? I've lost it. There it is. On that edge. So hopefully that'll let us slide that in, and then it'll snap down. Right? This will clip in just like this. The one thing that might be problematic is side to side, right? So this direction in that back plane, there's nothing holding it. Now it can't go too far one direction because we're going to hit this screw terminal on this clip. But I also am not overly concerned with it, right? I mean, it doesn't need to move, or it doesn't. Movement probably isn't going to be all that problematic if it does. If you were concerned about it, you could certainly, bring like this edge up so that it sits recessed, something like that. But I think what I have is fine. Now, as a final thing, I want to go look at this and then look at the board. So the clip's going to come in here near this hole, which is clear. Same thing here, it's clear. Here, there's nothing. And here, there's nothing. So that all looks good. Backside, I think we're fine. In fact, so these are 8mm standoffs here. So it's got an 8mm standoff, but we only have 5mm between it and the board. So we want to make sure that, these pins sticking through aren't going to be a problem. I don't think they are. Those only look like they're about 3 maybe. And 2mm sticking through. So we've got plenty of space for wires to come through all of that. I think we are good. So let's hide that. And so this is what my proposal for a first version of our backplane is going to look like. So save it. And now I'm going to export this body. It's a single body as a mesh. So I'm going to basically create it as an STL. And we're going to call it the YoshiStat Proto Backplane. Now I'm going to save this. Well, I'll have to create a folder for that. It's fine. All right. All right, now I'm just making sure that it got exported and all of that. Okay, so I've opened up Cura here, and I'm just going to take this backplane, drop it in. Seems reasonable. It's going to take 4 hours to print. Ouch. But there we go. That's probably going to do it for today. We've designed it. I'm going to kick off a print this out. Hopefully we'll luck out and first pass it will just snap right in. I doubt it'll be that good because I'm never that lucky, but it's a good start. Okay, before I sign off for the day, do I have any questions, comments? Let's go take a look at the stream. No questions. All right. Well, that's going to do it for today. Again, not a lot of code. Well, zero code. But there you have it. So that's it for today. We have designed the back plate for the YoshiStat prototype. Again, this is not the enclosure for a final thing, but to allow us to take the prototype, mount it to the wall, and actually start driving things. We'll see you again maybe next week. Next week is the weekend between Christmas and New Year's, so I might not be online, but otherwise, we'll see you in the new year. Thanks for watching.